Okay, so today we're just going to cover all the solutions to the moles to representative particles worksheet that I had previously assigned. So let's start with number one. You're given 2.5 moles of calcium chloride, and you're asked to determine the amount of calcium chloride molecules there are. So the unit conversion that we're trying to accomplish is going from moles to molecules. Now, molecules can just be stated as particles. It falls under that definition. So the bridge between these two units is known as Avogadro's number, which is 6.023 times 10 to the 23rd molecules per 1 mole. In this case, we're talking about calcium chloride, so it'll be per 1 mole of calcium chloride. Now notice how it has both of the units that we're trying to convert from and to. So we have moles right here at the bottom, which is what we start with, and it has molecules up here at the top, which is what we want to finish off with. So this is why this is the unit conversion that we're going to use. So you just start off with whatever your starting material is. So we have 2.5 moles of calcium chloride. And you're going to multiply it by Avogadro's number. The reason for that is you want this unit right here, moles, at the bottom. So when you do that, you have 6.023 times 10 to the 23rd molecules over 1 mole of calcium chloride. And this cancels out that unit, moles. When you divide moles of calcium chloride by moles of calcium chloride, the units cancel out, and what you're left with is molecules. And so, in order to do the math behind this, all you're going to do is take the two base numbers and then add in the scientific notation portion at the end. So you're going to do 2.5 times 6.023, and you get, we're going to round this down to 15.1. And then you're going to write that out and then add the 10 to the 23rd at the very end. So the solution should be 15.1 times 10 to the 23rd molecules. And this would be the final answer. For the next one, you're given 8.33 times 10 to the 23rd hydrogen atoms. So here we're working with atoms in the beginning. It's basically the same thing as saying particles. And you're asked to determine the amount of moles of hydrogen. So you're going from atoms as our starting unit to moles. So you're going to do the same exact procedure as you did previously. The conversion factor between the two is Avogadro's number, which is 6.023 times 10 to the 23rd. In the previous problem, we were talking about molecules as our particles. Here we're just talking about atoms. And it's per 1 mole of hydrogen in this case. So once again, we're going to use this as our conversion factor. Notice how it has our two units. We're going from atoms, which is at the top right here, and we're converting it to moles, which is at the bottom here. So we just start with what we were given. We were given 8.33 times 10 to the 23rd atoms. And now remember, whatever unit is up top, that same unit needs to be at the bottom of whatever you're multiplying it by in order to cancel it out. So you're going to flip this conversion factor. So you're going to have 1 mole of H over 6.023 times 10 to the 23rd atoms. Notice how it's the same exact conversion factor, you just flip the equation. So atoms divided by atoms cancel out. And notice how you have 10 to the 23rd here and 10 to the 23rd here. So you can just cancel those numbers out also. So when you plug this into the calculator, all you need to do is 8.33 divided by 6.023. And you get 1.38. So that would be your final answer. And remember, do not forget your units. In this case, it's going to be moles of H. Very next one, you're the question is, how many molecules of sodium chloride exist in 8.33 moles of sodium chloride? So you're starting off with 8.33 moles, and you want to get to molecules. So the unit conversion is moles to molecules. Here is Avogadro's number, 6.023 times 10 to the 23rd molecules. In the previous example, we were working with atoms, however, now our particles, molecules, over 1 mole of NaCl, sodium chloride. So again, we're just going to write down whatever we started with. We have 8.33 moles of NaCl, and we have to multiply that by Avogadro's number because we want moles of NaCl at the bottom in order to cancel this unit out. So you're going to multiply it by 6.023 times 10 to the 23rd molecules over 1 mole of NaCl. And so moles of NaCl divided by moles of NaCl are both going to cancel out, and the unit that you're left with is molecules, which is exactly what we're looking for. So the math behind this, it's going to be 8.33 times 6.023, and then you tack on that times 10 to the 23rd at the very end. So we'll just plug that in, 8.33 times 6.023, and you get 50.2. So the final answer should be 50.2 times 10 to the 23rd molecules. And if you wanted to, you could convert this into actual scientific notation. So this decimal would move 1 over to the left. So in reality, it should be 5.02 times 10 to the 24th molecules. Next one, determine the amount of formula units in 5.2 moles of water. So we're starting with moles of water, and we're asked to convert into formula units. So the unit conversion that you're trying to do is moles. Ooh, I have no idea what happened there. So the unit conversion you're trying to do is moles to formula units. Again, the bridge between those is Avogadro's number. So here it's going to be 6.023 times 10 to the 23rd. Formula units, I'm just going to abbreviate that into F.U over 1 mole of water. So we set that up. We have 5.20 moles of H2O, and you multiply that by Avogadro's number. When you do that, moles of H2O is being divided by moles of H2O, and your final unit that you're left with is formula units, which is exactly what you want. And so the math behind it, very similar to the previous problem, you just multiply 5.2 times 6.023 and then tack on the 10 to the 23rd at the end. So it'll be 5.2 times 6.023. We're going to round that down to 31.3. So this is going to be 31.3 times 10 to the 23rd formula units. Or you could change it to scientific notation, which would be 3.13 times 10 to the 24th formula units. Okay, so very last one. Find the number of moles of magnesium phosphate in 6.023 times 10 to the 24th molecules of magnesium phosphate. So you're given this amount of molecules, and you're asked to determine how many moles there are. So the starting unit is molecules, and the final unit that you're trying to find is moles. Here's Avogadro's number. Over 1 mole of magnesium phosphate, which is Mg3PO42. So we're just going to set it up with what we're given to begin with. We have 6.023 times 10 to the 24th molecules. and you have to flip Avogadro's number in order to make sure to cancel that unit out. So it's going to be 1 mole of magnesium phosphate over Avogadro's number. Now, molecules end up canceling out. And if you notice, you're dividing the same number by the same number. You're dividing 6.023 by 6.023, so those would cancel out. Notice how I'm not canceling out the 10 to the powers of, because they're different numbers. So, in order to solve that, we're just going to divide the two together. So 10 to the 24th divided by 10 to the 23rd. That's the same thing as saying 10 to the 24th minus 23. And so the final answer is going to end up being 10 to the 1, or just 10 moles of magnesium phosphate. The other way you could do this is convert this one into scientific notation and then do the division, but either way works